Hello everyone, today I'm presenting my new build. It's a new brass annealing machine that I built just recently based on very popular ZVS annealing board, the heating coil board, and I purchased this on Amazon. I believe I paid about $30. Also you can buy it on eBay. I know they selling it. So I did my design based on the parts I printed out on a 3D printer. This is completely my design. Build a 3D model and print it out. This box that fits the case and the case feeder mechanism, the body for the controller. I put it 20x4 LCD display with the rotary encoder here. Also printed the cases for the laser transmitter and receiver, base board for the ZVS heater, face plate for the PWM speed control, and a few parts I printed inside of the annealer. So you'll see it later on. I'll show you how the machine is built inside. So let me walk you through some controls on this machine I built, and it's pretty simple. I built it a really simple machine to use. Everybody will understand how it works, okay? Nothing complicated. So the controller, let me focus on the controller. Alright, and as you can see, there is some information in it, and to walk you through this, what I'm gonna do, I'm gonna first press reset button. So that reset button will initiate the process of the, like you turn on the machine, just plug it in the wall. So let me press the button. See, the controller starts initiating. It's supposed to say calibrating. Alright, and what it does, it starts rotating this drum, and the drum's supposed to stop at a certain position right here, so the machine knows it's ready to start a new cycle, so it knows where the drum is. Okay. Alright, so what we're gonna do is, today we're gonna anneal. I have 3 cases here, 6.5 Creedmoor that usually I shoot, and I tested this machine with 308 Winchester and 223 Remington. Works just fine, works with all these calibers, no problem. So today I'm gonna, for demonstration, use these 3 cases. I'm gonna load these cases particular way, so the case necks will facing the front of the machine. Alright, and I'm going to set the time in the controller, the time that I'm gonna to hit the case. Right, this for just demonstration. I'm gonna pick the random number, let's say 6.4 seconds. Right, the correct time is gonna be based on the time that will require to reach certain temperature, right? And for that purpose, I'm gonna use temp lag. Many of you knows how to use this. Basically, it's calibrated for 750 degrees Fahrenheit and 399 Celsius. So when temp lag changed its color, that means the temperature of the surface is reached that temperature, right? So that will be telling me how much time do I need to anneal that particular case. And all cases are different, even same caliber 6.5 Creedmoor, right, that I'm shooting, from different manufacturers can be different. Alright, Federal can make case thinner than, let's say, Hornady, or Hornady even thinner than Lapua. So every single batch of the cases will require its own time, and that that's why I'm going to use the template to determine the time that I need to anneal that particular case. Now, so we set 6.4 seconds for demonstration, and I'm gonna zoom out and to show you the whole machine. So we have cases inside of this box, and it's ready to start the annealing process. Okay, so what I'm doing is pressing the start button. Okay, and let's watch. Okay, first case in the drum, it's on its way to the loader. It's inside of the coil heating, and okay, first case is done. So the second case on the way, it's in there, it's heating now, and as you can see, it's heating. Okay, dropped. The third case is on the way, it's in there, heating. Done. So the three cases are done, right? And there's no more cases inside of the box. So what the machine is doing right now, it's rotating the drum, okay, and not detecting the case in the table, and it tells the machine, hey, there is something wrong, so most likely all my cases are done. So it's doing the 2 complete rotation, 2 cycles, after it's detected there is no cases anymore. So the next rotation is going to stop right here and stop the process. Let's watch. That's it. Alright, so the drum is stopped. Looking at the controller and what it says 3 cases are done, the annealing process is done, and that's pretty much it. Okay, so the idea of this machine is to load all cases you need to anneal, push the button and leave and do whatever you need to do, okay, and not just to sit and control or manually feed the annealing machine, and not to spend the time to do that. So I believe this is a very convenient way to do this process, and very safe. I'm telling you what, doing the open flame annealing, how I saw the other people is doing, probably fine for somebody, but in my environment, as you can see, it's my basement shop, everything is wood, and here's this my bench where I usually loading my powder, and definitely I always vacuum this after I've done with all my loading the cases. However, it's not safe to use open flame in this environment. Definitely, I would never do this in my basement. And probably the safest place is going to be outside. And right now it's warm probably here in Georgia. However, in a few months it's going to start raining, it's going to be cold, and it's not going to be pleasant to be outside. So, saying that, I believe this is machine really convenient and helpful, useful machine for the people who's doing the reloading and who's going to be doing the annealing process. I hope you enjoyed the process. Now I'm going to show you how the machine is built inside, and I hope you'll see the more details. So this is the machine. So I'm using just regular case from computer. So if you can see, here's a power supply. It's a 25 amp 24 volt power supply, switching power supply, and also I have a 12 volts power supply for my Arduino, and here's the Arduino board just behind the terminal block board, just for easy connection. I'm using the 4 relay board connected to Arduino, so I'm controlling solenoid, I'm controlling the induction board, and I'm controlling the motor. The motor is behind the box that's feeding the cases. Alright, and this is water-cooled coils, so all my water is in the tank. The tank is right there. I don't know if you see it or not. There's a pump on the bottom of the tank. Alright, let me see if I can show you. So the tank is just basically glass container right there, and it's a fishing tank, a water pump in there. It's pretty efficient. Alright, so I'm monitoring here the voltage and current, and this is my PWM module that controls the speed of my motor. Okay, that pretty much it. So here's a laser receiver, and here's a laser itself. So all these bodies I printed on a 3D printer as well. Okay, so this case for the receiver and transmitter laser. So right here, if I put my finger, you'll see that the laser will be kind of interrupted, so the receiver will not receive the signal. So that means that machine knows the case inside of the hole, inside of the coil, and it will start annealing the process automatically. Okay, on top I put a cooling fan, so it's evacuating the hot air from the case, because the annealing board generates lots of heat, and I need to cool down my components inside. Alright, that's pretty much it. Thank you for watching, and have a nice day, guys.